The next unit that we'll be talking about is called Math and Measurement. We talk about math and measurement in chemistry because of a variety of reasons. First, we use a lot of math in chemistry. You'll find as we progress through the year, we'll practice your graphing skills, we'll practice your algebra skills, and we'll practice your simple arithmetic skills. We also need to learn about the mathematics of science. In fact, math in science can almost be like its own language. It tells people how we conducted our experiment and how accurate our equipment was. To do that, we need to know a little bit about metrics, measurement, and manipulating numbers, which is adding and subtracting and dividing and multiplying. But sometimes you have to realize that the math that we deal with in science can be different than the math that you deal with in math class. There are two kinds of measurements that we can take, and you've both practiced all of them. The first one is called qualitative. Qualitative comes from the word quality, which means a descriptive measurement. You're trying to describe something. You've practiced this a lot when we did our observations lab a couple of weeks ago. These measurements do not have any numbers involved, and they could be things like, what color was it? Did it form a precipitate? And did the reaction get hot or cold? The other kind of measurement is called quantitative. Quantitative comes from the word quantity. Quantity means numbers. So quantitative measurements all involve numbers. And numbers don't mean anything unless you have units with them. We've already seen this when we took measurements for our separations lab, and you had to record whether or not something was grams or milliliters. If you don't have that label on there, if you don't have the unit with that number, there's very little information we can get from that number. Is it grams? Is it milliliters? Is it kilograms? Is it degrees Celsius? You have to have a tag or a label with your numbers. Those tags that we use a lot of times fall under something called the System International of Units. These are kind of like the standard units that most of the world uses. It's called a modified metric scale. Most of the units come from metrics, with a couple of exceptions. We use metrics because the calculations and the measurements are much easier. Instead of having to deal with fractions, 2/16, 3/16 of an inch, we can deal with decimals. Everything is based on the number 10. This also makes changing between different units much easier. All you have to do is move the decimal, and we'll talk about how to do that at the end of this PowerPoint. As a side note, in case you're interested, there are only 3 countries in the world that don't use the metric system: Burma, Liberia, and the United States. Not exactly world powers joining us. There are 4 System International units that we will need to know. The first one is length. The International System unit for length is the meter. The symbol for meter is a lowercase m. The meter was derived by taking the distance from the equator to the North Pole and chopping it up into 10 million pieces. So 1/10,000,000th of the distance from the equator to the North Pole is 1 meter. For us, we need to know that the meter is just a little bit longer than a yard. It's about 3 inches longer than a yard. The second System International unit is for mass, and it's called the kilogram. The symbol for kilogram is kg. A kilogram was defined as the mass of 1 liter of water at 4 degrees C. We know that water freezes at 0, so this is just above the freezing point, so it's pretty cold water. We also need to know that 1 kilogram is equal to 1,000 grams. And grams are actually the metric base unit for mass. And we'll talk about that at the end of this PowerPoint as well. The third System International unit is seconds, which measures time. The symbol for seconds is a lowercase s. This was defined by taking the mean solar day, mean as in average, as in math class, take the average day based on our sun and chop it up into 86,400 pieces, and that's what a second is. The last System International unit is for volume, and that is the liter, and its symbol is an L. Sometimes you see a lowercase l. I usually use a capital just so you don't think that it's a capital I. One thing we need to know about volume is that it can also be expressed as cubic units of length. This comes from the fact that if you're going to find the volume of a cube, I hope you know from geometry, you would take length times width times height. Take all those three things and multiplying them together, and then you would get a cubic unit, like centimeters cubed. So 1 liter of liquid would be equal to 1,000 centimeters cubed of liquid. You could also say that 1 milliliter of liquid would be equal to 1 centimeter cubed of liquid. Now let's do some practice problems of what you'll need to do on part of your homework for tonight. We need to practice our metric conversions. So to do that, first of all, we need to know how to do metric conversions. To do metric conversions, you need to count the number of steps that you need to go from one measurement to another, and then you move the decimal in your measurement, that number of steps, and you move in the same direction. So which steps do we need to know? There are 7 basic steps in the metric system. These are listed out in your packet towards the front. There are a few reference pages there for you, and one of them is called Stepping Through the Metric System. That page shows you the 7 main steps for the metric system: kilo, hecta, deca, the base unit, which can be meters, liters, seconds, or grams, deci, centi, and milli. These are the 7 main steps of the metric system. These are the ones you will need to memorize. To help you with that, there are a couple of sentences that you can use. The first one goes like this: King Henry died drinking chocolate milk. The problem with this sentence is that it expects you to remember that the base unit comes right in the middle of the sentence. If you use the next sentence, then you don't have to remember that on your own. Kittens hate dogs because dogs can't meow. Kittens hate dogs because dogs can't meow. That gives you the letters to the 7 basic steps in the metric system that you need to know. Now let's do some examples. Here are our 7 steps again. And here's what we would like to find. So pick up your pencil and play along. We're starting with kilometers. When you see this symbol right here, km, the K tells you the prefix, the M tells you what you're measuring. We're measuring meters here. So we're going to start on the kilo. Pick up your pencil, put it on the kilo. We need to go to centimeters. So we're going all the way down to centi. So put your pencil on the kilo and then start counting. 1, 2, 3, 4, 5. And we moved to the right. So now we need to take our decimal point from where it is right here and take it 5 steps to the right. 1, 2, and then we'll have to put in 3 more zeros. 1, 2, 3, 4, 5. And you'll see that this is our answer. 203 million centimeters. Oops, 203,000 centimeters. And let's check those places again. 1, 2, 3, 4, 5. One more example. Here's our 7 steps. Kittens hate dogs because dogs can't meow. And here's what we'd like to find. We're starting at ml. The first letter tells you the prefix, which is milli. The second letter tells you the base, which is liters. So we're starting at milli. Put your pencil on milli and decide where you need to go. Over here we have a capital D and an L. The capital D goes with deca. If it had been a little d, it would have been deci. So capital D means we're going to deca. So put your pencil on milli and start counting. 1, 2, 3, 4. And we move to the left. So we need to take our decimal place and go 4 spots to the left. Now where is the decimal if you don't see it? The decimal always starts at the end of the number or at the right side of the number if you don't see it. So we're starting right here next to the 3. And we're going 4 spots to the left. So we'll start right next to the 3. 1, 2, 3, 4. So we'll need 2 zeros in front of our 6, 3. And I put this last one here right in front of the decimal just kind of as a flag. It draws your attention to the fact that there's a decimal here. But if you left that 0 off, it would still be correct. So 0.0063 decaliters. Your homework tonight is the metric conversions worksheet as well as the algebra worksheet. Both of those will be checked on Wednesday for stamps when I get back. Good luck!